Hello friends, in today's video I'm going to show you a demonstration of a temperature transmitter I've built implementing Modbus TCP IP protocol. We've been told that a transmitter compared to a transducer is a device that provides a standard output representing a physical variable. On the field we can find devices that implement digital protocols or have digital protocols capabilities. Here we have an example of a transmitter that provides information about gas density, temperature, and pressure through Modbus digital protocol. Okay, so we're going to briefly review these three items on the video: the Modbus protocol parameters, sensor characteristics, and the microcontroller POC interface. Regarding Modbus parameters, we're going to use the function code number 4, which is meant to read analog input registers from a register range that goes from 30,001 to 39,999, and a Modbus mode 0 for such Modbus function code. Now let's take a look at the temperature sensor we're going to use, which is the DS18B20. This sensor can be powered from 3 volts to 5.5 volts and can measure temperatures from minus 55 Celsius degrees to 125 Celsius degrees, which is a good range for most of the applications. It has an accuracy of plus minus zero point 0.5 Celsius degrees, and the resolution is user selectable from 9 to 12 bits. Um, this device can convert 12 bits digital word in a period of time of 750 milliseconds. It can be used in thermostatic controls, industrial system, customer products, thermometers, or any other thermally sensitive system. The data is stored in a 16-bit sign extended to complement number. And as we know that the sign bits indicate if the temperature is positive or negative, being 1 as negative and 0 as positive. The nibble that is at the right is meant to represent the decimal section of the entire number, and the 5 bits at the left are meant to represent the sign of the number. So we know that the 2's complement representation is useful for negative values and is given by this formula. So I have created a C++ program in order to exercise such table. As you can see, we can represent negative values once we know the bit distribution. You can use the formula, or you can subtract one unit and flip the rest of the bits. We're going to use this processing inside the POC program. Here we have the sensor word being received in the PLC. I'm currently hitting with my hand the tip of the sensor in order to change the data. So the documentation has stated that the sensor will provide 16 bits. It's a word length, and those bytes are going to be processed inside the PLC program. This is a brief summary of the data being collected. Regarding the internal wiring, we're going to use only one slave and a single pull-up resistor connected to the microcontroller. For prototyping, I've used this module to get access to the Ethernet network, which implements SPI communication protocol. Um, I'm about to show you a test using this wired configuration first, but since I'm using TCP/IP, I can use its flexibility in let's say a wireless connection for a remote point in a process, for example, with no wiring accessibility. This could be a nice application for such scenario. Now let's see it running. I've used two pilot lights indicators for a high and low temperature thresholds, which can be configured in the runtime. I have also placed a trend view object and a gauge for a graphical representation of the process temperature. Currently, the temperature is under low threshold, so the green indicator is on. Once the process temperature exceeds this low threshold, then the amber indicator will turn on and the green indicator will turn off, as it is happening now. All the tests we're going to compare uh, the temperature with the analog thermometer so we can check the accuracy of the temperature being read by the sensor. Right now the temperature is exceeding the high threshold and the red indicator has turned it on. Okay, so as a summary, we've got a nice result on this test. Once we have tested this wire configuration, um, we can test the wireless configuration in a remote process location. So now let's test the remote process location. So let's say this is the setup. We're going to heat the water and we're going to let it cool. Since I was running out of battery, I needed to introduce some ice cubes to get the temperature low. As a conclusion of this proof of concept, we can say that we have got pretty accurate results, and we can expand this functionality to other physical variables, and the strategy would be the same.
Thanks for watching.